Okay, let's go ahead and take a look at chapter 12. Keep in mind that 12, we're going to actually use three different charts. We're going to use a chart to find the future value, we're going to find a chart to find the present value, and we're going to use a chart to find out what the daily value of something would be in the future. Whenever we're looking into the future, we invest something today and we get that amount in the future. When we're looking for present value, we look into future and find out how much are we going to need. So what do we need to invest today to get that amount in the future? That would be present value. And then the compounded daily would also be another future value type of problem where we want to know what the amount would be, the compounded amount would be in the future. This first problem, drill problems for chapter 12, remember these are all lump sums that we're looking for. And this is a 2-year investment, and it's compounded twice a year, semi-annually, at 4% interest for $1,250. So we're not going to use a table on this particular problem, and so we'll take 2 years times being compounded semi-annually, which is twice a year, so that's 2 times 2 to give us 4 periods. And then we take 4%, the rate that we're actually going to use, and divide it by the number of times it's compounded in a year. It's semi-annually, so that's twice a year. So 4% divided by 2 gives us 2%. So with 2%, I'm going to go for 4 periods. And the 1250 is 100% of the value plus a 2% increase. Add 100% of the 1250 to the 2% increase is 102%. Move the decimal point 2 places to the left, which is 1.02. Multiply the investment to 1.02, and that gives you the end of the first 6-month period of $1,275. Then take $1,275 times 1.02 again for the 2% increase, and that would give us the end of year 1 of $1,300.50. Then at the beginning of year 2, we take $1,300.50 and take that times 1.02, and at the end of the 6-month period, since this is compounded semi-annually, so we're halfway through the year of year 2, it will compound out to $1,326.51. And then finally, the end of year 2, the 4th period, is $1,326.51 times the 1.02 will give us the end of the year value, the compounded amount of $1,353.04. How much did I earn? We'll take the difference between the compounded amount or the future value, which is $1,353.04, subtract out the initial investment of $1,250, and that means we earned over that 2-year period, compounded 4 times, semi-annually, twice a year, of $103.04. Okay, now I'm going to go ahead and take a look at number 2. Number 2 is 12 years. It's a 12-year investment, and it's an investment of $15,000. And it's going to be compounded annually. So the number of periods is times 1, which is annually, which is equal to 12 periods. And then the rate is 3.5% divided by 1, which is equal to 3.5%. So we are going to find the corresponding factor of 12 periods and 3.5% on a future value table. Let's see if I can go back to that previous screen and grab a table from there. Okay, so this particular table is a future value table based upon $1 per period at I% for n periods. And so this is for a 12-year period, which is right there at 3.5% of 1.5111. So there's the factor right there. We're going to take 1.51 0.5111 times the investment of $15,000, and then that will equal the compounded amount of $22,666.50. How much interest did I earn? Well, just subtract out the initial investment of $15,000, and that will equal the interest. And the interest will be $7,666.50. Okay, let's take a look at number 3. Okay, number 3 is a 6-month investment. We're going to invest $15,000 for 6 months. At a compound rate of 6%. It's compounded semi-annually. Okay, so therefore, it's 6 months in 12 months times twice a year. The number of times it's compounded each year is equal to 1 period. And then it's 6% divided by twice a year, which is equal to 3%. Okay, so we are going to look to the future to find out what this $15,000 will turn into in 6 months. So I'm going to find the corresponding factor of 3% in 1 period. Okay, so 3% in 1 period is 1.0300 right there. It's 15,000 times 1.00300, and that would equal the compounded amount of $15,450. Subtract out the initial investment of $15,000. That means only $450 was earned over that half-year period of that it was invested. So it wasn't invested for a very long period of time. Okay, then we're going to go ahead and take a look at number 4. We're going to invest $15,000 again. 8% interest, compounded quarterly. For 2 years. Again, we're going to look into the future to find out what this will turn into in 2 years. So we're going to take 2 years and multiply that times 4 times a year, the number of times that it's compounded, which is quarterly, and that will give us 8 periods. And then take 8% and divide it by 4 times a year, the number of times it's compounded, and that will give us 2% that we'll use on the future value chart. So we're going to find the corresponding factor of 8 periods and 2% on that future value chart. And that would be $15,000 times 1.1717, and that equals a compounded amount, or the future value, of $15,575.50. I'm going to subtract out the amount of the initial investment of $15,000, and that gives us interest of $575.50. Oh, you know what? I made a mistake. Scratch that. the 15,000 times 1.1717 is not 15,000. It is 17,000. $17,575.50. Then subtract out the $15,000 investment, meaning that we earned $2,575.50. Okay, number 5. And again, remember these values may be different than what you have in Connect or in the version of the textbook that you're using because of algorithms. We're going to calculate the effective rate on this one for interest for 1 year. We want to find out what the true rate of interest is. So we have the principal of $15,500. And interest rate is equal to 12%. It's compounded quarterly. And let's see. First of all, we're going to take, this is based upon 1 year. So therefore, we are going to take 1 year times 4 times a year, gives us 4 periods. And then take 12% divided by 4 times that it's compounded a year to give us 3% that we'll use on the future value chart. So 4 periods and 3%. Actually will give us a corresponding factor. Let's go ahead and look at that same future value table. I'll pull that one back up again. Okay, 4%, 4 periods and 3% is 1.1255. And that will give us a compounded amount of $17,445.25. And we'll subtract out our initial investment of $15,500, and that will give us the interest of $1945.25. Okay, if we're trying to find the effective rate, rate is equal to interest divided by principal times the time. So therefore the interest is $1945.25 divided by the principal of $15,500 times the time, which is 1 year. So that's the same as $1945.25 divided by 15.5, and that will equal the rate, the effective rate of 0.1255. Move the decimal point 2 places to the right, which is 12.55% when rounded to the nearest hundredth. Okay, so that's the true rate. Effective rate is always slightly higher than the stated rate of 12%. Okay, let's go ahead and look at the next question. In my scenario, it says use the correct table and calculate what 700 would grow to. What $700 would grow to at 6.5% interest per year, compounded daily. Key component right here is compounded daily. I'm going to use a daily chart on this particular problem. Okay, let's see if I can find a daily chart on this one. Okay, nope, that's not it. Okay, yeah, this is it right here. And so with the compound daily chart, let's see, let me grab this one right here. It's going to have the word daily on it. Remember the one that we used earlier for the first few problems? That was a future value chart to find a lump sum of what an amount would be in the future. But the daily chart has a chart all of its own. So we are going to find, and we're not going to have to break this one down. We're just going to go use 6.5%, 7 years. So here's a 6.5% right there, in 7 years, that's 1.5761. That's a corresponding factor. So take 700 times 1.5761, and that will equal the compounded amount or the future value of this investment of $1,103.27. Okay, now this next problem says complete the following using the present value table or the present value table in the Business Math Handbook, either one. And the amount that we desire at the end of the period, we want $6,000 at the end of our period. Okay, this is for 8 years, and it's at 3%, and it's compounded semi-annually. Okay, we're going to do this the same type of problem, but we're going to use a different chart to calculate it. In 8 years, we want $6,000 compounded semi-annually at 3%. What must we invest today to get that $6,000 in 8 years? So I'm going to do what I did in the previous problems. I'm going to take 8 years times twice a year, which is semi-annually. That's going to give me 16 periods. Then I'm going to take 3% divided by semi-annually, which is twice a year, to give me 1.5%. So I'm going to go to the present value table and find the corresponding factor of 16 periods and 1.5%. Let's see if I can find one quickly here. Okay. Okay, note that it says present value at the top of this particular chart. And I want 1.5% right there. And I want 16 periods. So there's 16 periods. And 1.5% is 0.7880. Okay, so that's the corresponding factor, 0.7880. So I'm going to take $6,000 times 0.7880, and that will equal the present value of $4,728. Okay, so therefore we need $4,728. We need to invest it today. That's a present value for 8 years at 3% interest compounded semi-annually if we want to get $6,000 in that 8-year period, 16 periods later. So today we must invest $4,728. Okay, the next problem is we want $8,900 in 4 years at 6% interest, compounded monthly, 12 times a year. What must we invest today in order to get $8,900 in 4 years? So I'm going to find, first of all, I'm going to break it down. It's 4 years times 12 times a year, that's monthly. And that will give us a number of periods that this particular lump sum would be compounded. So that would be 48 periods. Then I'm going to take 6% and divide that by 12 times a year. And that would give us a 1/2%. So I'm going to use that present value table again. In fact, I'm just going to put PV out here, out to the side just to remind you on this one. And I'll take $8,900 times that corresponding factor of 48 periods and 1/2%. Okay, this is going to be harder to see. 48 periods, and is that first column 1/2%? It sure is. So it's only the first column, and it's 0.7871. So we'll take that times 0.7871, and this will give us the present value, what must be invested today in order to get $8,900 in 4 years. And that amount would be $7,005.19. So today we must invest $7,005.19 if we wanted to receive $8,900 in 4 years, if the account or the investment were compounded at 6% interest for 4 years monthly. Okay, then number 9, we in 7 years we want $17,600. It's in 7 years. At 12% interest, compounded quarterly. Okay. First, I'm going to go ahead and break this down. I've got 7 years times 4 times a year. It's quarterly, so that's going to give us 28 periods. Then we're going to take 12% interest and divide it by 4 times a year. The number of times it's compounded in a yearly basis will give us a new rate of 3%. So we're going to use a present value table here, and the reason we're going to use a present value table is because we want to know what we must invest today to get $17,600 in 7 years if we were able to invested at 12% interest compounded quarterly over that 7-year period. So I want to find the corresponding factor of 28 periods and 3% on a present value table. Okay, 28 periods and 3%. Right there, 0.4371. So I'll take $17,600 and multiply that times the corresponding factor of 28 periods and 3% on the present value table to give me 0.4371. And that will give me the present value of $7,692.96. Okay, this next problem, we need $20,000 in 20 years. And if we can find an investment that's 8% interest, compounded annually, what must we invest today in order to generate $20,000 lump sum in a 20-year period? So we take 20 years times the number of times it's compounded in a yearly basis, which is annually, so that's 1, so that's going to give us 20 periods. And then we're going to take 8% interest and divide it by the number of times it's compounded in a year, which is 1, and that'll give us 8%. So using a present value table once again, we are going to find the corresponding factor of 20 periods and 8%. %. Believe that one's it right there. Oops, I lost it. Okay, but you do find the corresponding factor. I think I lost that one on there really quickly, but I'll just tell you which one it is. And we'll take $20,000 times the present value corresponding factor of 0.2145, and that will equal the present value of $4,290. Therefore, today we'll invest $4,290 so that in 20 years at 8% compounded annually, we can generate $20,000. Today's investment in the present is $4,290. Okay, let's go ahead and take a look at the summary practice test at the end of the chapter. And the first problem is, okay, Lorna Ray. She's the owner of a Starbucks franchise, and she loaned $40,000 to Lee Reese to help him open a new flower shop online. Lee plans to repay Lorna at the end of 5 years with a 4% interest compounded semi-annually. How much will Lorna receive at the end of 5 years? That's a key component. The question there is how much will Lorna receive at the end of 5 years? That means she wants to know the future value. If she invests $40,000 today, how much will she have in 5 years? So this is just a future value table. Remember, there's 3 tables in this chapter. The future value table to find the compounded amount, and the present value table to find out what you invest today to get a certain amount in the future, and then the compounded daily chart, which that one's the easiest because you don't have to break down anything and just use a chart and multiply the factor times the amount of your investment to get your future value. So on this one right here, all we're wanting is a future value. What will $40,000 turn into in 5 years if it's compounded semi-annually at 4% interest? So the first thing we're going to do is take 5 years times the number of times it's going to be compounded in a yearly basis, which is twice. So that's going to give us 10 periods. Then we're going to take 4% interest and divide that by twice a year, the number of times it's compounded in a yearly period, to give us 2%. Okay, we're going to use a future value table and find the corresponding factor of 10 periods and 2%. Okay, there's 10 right there, and 2% is 1.2190. 1.2190. And so we'll just go ahead and take the $40,000 and multiply that times the corresponding factor of 10 periods and 2%, which is 1.2190. And that will equal the compounded amount, or the future value, of $48,760. Okay, that's what the $40,000 will turn into in 5 years, compounded twice a year at 4% interest, it will turn into $48,760, meaning that you only made interest over that 5-year period of $8,760. Okay, let's go ahead and take a look at number 2. Joe Beery wants to attend Riverside College. 8 years from today, he will need $50,000. Okay. If Joe's bank pays 6% interest, compounded semi-annually, what must Joe deposit today? What must Joe deposit today? That means we're going to look at a present value. What lump sum must Joe deposit today to have $50,000 in 8 years? We're going to use a present value table. First, we're going to take 8 years times the number of times it will be compounded in a 1-year period, which is twice for semi-annual, to give us 16 periods. And then we'll take 6% divided by twice a year to give us 3% for the present value table. So 16 periods and 3% in a present value. Okay, there's 3% right there, and 16 periods is 0.6232, I believe. 0.6232. Let's multiply that times $50,000. And that will equal the compounded amount, or, excuse me, not the compounded amount, that will equal the present value, the amount that we're going to invest today of $31,160. That's the amount that we invest today so that we can generate $50,000 in 8 years, compounded twice a year at 6% interest. Okay, let's go ahead and take a look at number 3. Shelly Katz deposited $30,000 in a savings account. At 5% interest, compounded semi-annually. At the beginning of year 4, Shelly deposits an additional $80,000. Okay, in year 4. At 5%, compounded semi-annually. At the end of year 6, what is the balance of Shelly's account? Okay, so they kind of threw a little extra problem in there to make us work a little bit harder on this one. So the first thing we're going to do is remember that whenever you're compounding interest, it's compounded at the end of each period. So if it's semi-annually, it's compounded at the end of the first 6 months and then at the end of the next 6 months, which would be at the end of the year. Okay, so since Shelly Cash deposited $30,000 in an account at 5% interest compounded semi-annually at the beginning of year 4, Shelly deposits an additional $80,000 at 5% interest compounded semi-annually. At the end of year 6, what is the balance in Shelly's account? So first of all, I'm going to find the number of, I'm going to calculate the first part based upon 3 years, because it's not until the beginning of the 4th that she makes the next deposit. So I'm going to base this first part on 3 years, and 3 years times twice a year gives you 6 periods, and that's 5%. divided by the number of times you compound it annually, which is twice a year, and that would give me 2.5%. So on a future value table, to find out what the value would be at the end of that 3-year period, I'm going to find the corresponding factor of 6 periods and 2.5%. Okay, that future value table is, I'm going to take $30,000 and then multiply that times the corresponding factor on the future value table of 6% and 2.5 periods, 2.5%. That would be 1.1597, and that would equal the compounded amount or future value of $34,791. Okay, then in year 4, I'm going to deposit $80,000. That's going to give me a total amount at the end of year 3, beginning at the beginning of year 4, by the way, of $114,791. And now I want to find out what the compounded amount would be at the end of 6 years. So I'm going to take that times the corresponding factor of 6 periods and 2.5% on the future value table, which is still 1.1597, and that would equal the future value of $133,123.12. Okay, number 4. Earl Miller, owner of Papagino's franchise, wants to buy a new delivery truck in 6 years. He estimates that the truck will cost $30,000. If he invests $20,000 now, at 5% interest, compounded semi-annually, will Earl have enough money to buy his delivery truck at the end of 6 years? Okay, so first of all, I want to look at it 2 different ways on this one. So first, to compound it, I'm going to take 6 years times the number of times it's compounded in a year, which is twice, to give us 12 periods. And then take the 5% divided by the number of times it's compounded in a year, which is twice, to give us 2.5%. And on the future value table, I'm going to find the corresponding factor of 12 periods and 2.5%. So I'm going to take the amount that I invested of $20,000 times the corresponding factor of 12 periods and 2.5% using the future value table, which would give me the corresponding factor of 1.3449. And the future value would be $26,898. So he needed $30,000. He did not quite make it with his investments, so that did not work correctly here. Okay, let's see. So will Earl have enough money to buy his delivery truck at the end of 6 years? No, he will not. He still lacks a little bit. Okay, number 5. Minnie Rose deposited $16,000. in Street Bank 6% interest, compounded quarterly. What was the effective rate? Round to the nearest hundredth percent. Okay, whenever we're doing these types of problems, I'm going to use the future value table to find out what the value, actually I'm looking for the amount of interest that she's going to earn on this particular account and divide that by the amount of her investment times 1 year. This is going to be based upon 1 year. So that would be 1 year times the number of times it's compounded, which is 4 times a year, will give us 4 periods. And then it's 6% interest divided by 4 times in a year to give us 1.5%. Okay, I'm going to use a future value table and find the corresponding factor of 4 periods and 1.5%. Okay, 4 and 1.5% is 1.0614. Take that times the amount of the investment of $16,000 times the corresponding factor of 1.0614, and that will give us a compounded amount, or the future value, of $16,982.40. I'm going to subtract out the amount of the investment of $16,000, and that will give you the interest of $982.40. Okay, now I can calculate this. Rate is equal to interest divided by the principal times time. So that's interest of $982.40 divided by the principal of $16,000 times 1 year. So that's $982.40 divided by $16,000, and that will give you, after you move the decimal point 2 places to the right, 6.14%. Okay, number 6. Lu Ling, owner of Lu's Lube, estimates that he will need $70,000 for equipment in 7 years. Lu decided to put aside money today so that it will be available in 7 years. Real Bank offers Lu 6% interest, compounded quarterly. How much must Lu invest to have $70,000 in 70 years? What that's asking is, what do I invest today in order to get that $70,000 in 7 years at 6% interest compounded quarterly? So I need to use a present value table. Okay, so I'm going to take 7 years and multiply that times the number of times it's compounded in a yearly basis, which is 4, and that will give us 28 periods. And then I'm going to take 6% interest, divide it by the number of times it's compounded in a year, which is 4 times, and that would give us 1.5%. So now I'm going to go to the present value table and find the corresponding factor of 28 periods and 1.5%. Okay, 1.5% is this third column, and then 28 periods is 0.6591. So I'm going to take the amount that I need of $70,000 and multiply it times the corresponding factor on the present value table of 0.6591. And that will equal the present value of $46,137. So today I must invest $46,137 if I want to get $70,000 in 7 years. If my investment is invested at 6% interest compounded quarterly. Today's investment is $46,137. Okay, let's look at number 7. Bernie Long wants to retire to California when she is 60 years of age. Bernie is now 40. She believes that she will need $900,000 to retire comfortably. To date, Bernie has set aside no retirement money. If she gets 8% interest compounded semi-annually twice a year, how much must Bernie invest today to meet her $9,000 goal? So again, this is going to be a present value table. What do we invest today to get $900,000 in 20 years? Okay, because she wants to retire when she's 60, and currently she's 40, so in 20 years. So 20 years times the number of times it's going to be compounded in a year, which is twice, is going to give us 40 periods. And then 8% interest divided by the number of times it's compounded on a yearly basis will give us 4% interest using the present value table. So 40, find the corresponding factor of 40 periods and 4%. So we'll take 900,000 and multiply it times the corresponding factor of 40 periods and 4% on the present value table of 0.2083. And that will equal the present value of $187,470. So today she must invest $187,470 if she wants to get $900,000 in 20 years at 8% interest compounded semi-annually. Okay, then finally, one more. Jim Jones deposited $19,000 in a savings account at 7% interest compounded daily. Okay, that word daily means we'll use the daily chart. At the end of 6 years, what is the balance in Jim's account? So it's going to find the future value using the daily chart of 7% in 6 years. Okay, here's 7% in the third column. In 6 years is 1.5219. Going to take the $19,000 times the corresponding factor of 6 years and 7% on the daily chart, and that corresponding factor is 1.5219, and that will equal the future value of $28,916.10. Okay, the key component in Chapter 12 is that we're finding lump sums. We will use one of 3 charts depending on what the question is asking. We're going to look, if we're looking into the future, to find out what our investment today is going to yield in a certain period of time, then we're going to use a future value chart. If we know that something is going to cost a certain amount in the future, what must we invest today to get that certain amount in the future? Then we'll use a present value chart. And then if we are going to compound a savings account or something to that effect, and it's compounded daily, use the daily chart. And this one we don't have to break down the percentages or the number of years. This concludes Chapter 12, Compounding Interest. It's lump sums and lump sums only. As we move into the next chapter of 13, It will calculate based upon streams of payments, like monthly payments or quarterly payments or yearly payments, something to that effect. That's why they call Chapter 13 the chapter on annuities.